This illustration deals with general purpose circuits. Used to, the 3 VA per square foot was in table 220.12 for dwelling units. Now the 3 VA per square foot has been relocated and renumbered as 220.14J. And then, of course, after the total calculation of a dwelling unit is made, table 310.12 will allow you to downsize your service based upon the full load amps of a service. For example, if you came up with a 4-aught conductor, calculated either standard or optional calculation, you could drop it down from a 4-aught to a 3-aught by using table 310.12. So with that thought in mind, we're going to calculate the general purpose circuits. Those circuits are the circuits that would serve the entire dwelling except for the small appliance circuits and direct circuits. Now, as electricians, you know, we looked at a dwelling unit as electricians, and I'm speaking from an electrician's point of view. We would have 3 circuits: the 3 VA per square foot circuits, the small appliance circuits, and the direct circuits, such as 2 AC units or heating unit, for example, but it'd be a direct circuit. So this illustration is just going to deal with a general purpose circuit, so let's kind of get on with it. We have a 2,700 square foot dwelling unit, and we reference that you should also see chapter 22-2 for more information if you wanted a little bit more detailed information on an entire calculation. But notice step 1. We reference 220.14J, and we are instructed to use 3 VA per square foot for a dwelling unit. 220.11 deals with the square footage that we picked up at 2,700 square foot, and naturally that wouldn't include porches and things like that. It would just be the outside dimensions that would give us the square foot area. Step 2, we take the 3 VA per square foot times 2,700 square foot. We come up with 8,100 square foot. Now, notice the number of circuits we would need by code now is in step 3, 210.11a. We would take the 8,100 VA, divide it by 1,800 VA, and we would come up with 4.5. Now, the 1,800 VA came from 15 amp size overcurrent device times 120 volt. We come up with 4.5, and that's a round up to 5 circuits. And then you could take 5 times the 1,800 VA, and you see we do exceed the 2,700 square foot, so the 5 circuits would supply that. But notice in the 1,800 square foot, we could have as many outlets as we wanted per code. So some cities, counties, and states, they would limit the number of outlets that are allowed on a general purpose circuit. For example, they may allow only 10 circuits on a 20 amp device. And when I say 10 circuits, 10 outlets. And on a 15 amp circuit, they would only allow 8, or they may go 10 and 13. But many times it's a limitation on the number of outlets by the state, county, or city. But if not, if there's no limitation, electrical ordinance that changes the NEC's requirements, then you could put as many outlets as you wanted in the square footage of 15 times 120, which would be 600 square foot. You put as many as you want. A 20 amp overcurrent device times 120 volt supply would be 800 square foot, and you could put as many as you wanted in that area, see. So sometimes cities say, nah, we don't want to go along with that and find 26, 30 outlets on a 20 amp circuit. We're going to limit you there. And then we'll talk more about the other circuits as we get into these illustrations. But all this illustration is showing how we would get in step 2 the square footage area of the dwelling. And then in step 3 is showing how many circuits it would take to take care of the 8,100 square foot. Now, if you want to look at this in a more detail, just go to the figure 22-2 in chapter 22 of the volume 2 of Stallcup's Designing Electrical Systems, or just go through with us chapter by chapter, reviewing the areas that you're concerned with. Now, with this thought in mind, we'll move to the next illustration.